Today we will have revision about geometric transformations. I want you to open your books, page 378. And the first question, the question is graph each point and its image after the given translation. Name the coordinates of the image. Okay, I'm not going to do the graph. I want you just to give me the coordinates of the image of the first one, D, 3 and 2, with translation to the right 3 units. Abdullah, okay?
We will write go right, that we will move x.
Great.
That will be 6 and 2.
Great. So it will be 6 and 2. Excellent. The second one.
Can I answer, mister?
Yes.
It will be -5 and 0.
Down 4 units, so it will be subtract 4 from y. Excellent. And the next one, number 3. Muhammad Abdul Baqi.
Yes, mister.
Number 3, 1 unit up and 4 units to the left. So what? Yes, what we do for x?
X will be to
Add 1 or subtract 4.
I will add 1.
Up and down for y-axis and left-right for x-axis. So left 4 units, subtract from x-axis, subtract 4 from 0, and add 1 to 6. Right? Can you give me the coordinates?
Yes, mister.
So it will be
So it will be 1 and 2.
again.
1 and 2.
No. Don't add 1 to x. Subtract 4 from x. This 1 is up.
So
it's-
it will be -1.
No.
-4.
Yes. Right.
-4 and 7.
Great. -4 and 7. Okay. In this question, we have. Okay, guys, you can do this. You can do the graph by yourself, and when you translate the figure 2 units to the left, you will get this image, and when you translate it 3 units up, you will get this image. And in number 6, when you translate 3 units right and 1 unit down, you'll get this one. Okay, guys, I want to tell you how to do this using GeoGebra. Do you remember the program GeoGebra? This one. Can you see the GeoGebra? Or it's still the presentation?
Still the presentations.
You can see the presentation, okay. Okay, now you can see GeoGebra, right?
Yes.
Okay, using this program you can do many things in math. I want first to tell you the difference of these parts. What's important for us, the first one, graphing, is when you want to graph a function. You have a function, a linear function for example, and you want to draw the linear function, graph the linear function. Okay, so this is the first one. You have a function and you want to graph the function. If you have you have points and you want to plot the points. Okay, also here in geometry you have the same in graphing and additional properties for geometry, and this one for 3D graphics. Today we will use geometry. When I use geometry I will get this. Since in geometry there is no big need for the coordinates, but in our case I need the coordinates, so I will use the coordinates. How to do this? Right click and choose axis. You'll get the axis, the x-axis and the y-axis, and grid. You'll get the grid. Now you can move, use this, move, and move it as you want. Okay, how to draw? Let's draw. I will choose from here a polygon. I have the polygon that is given in the question, this one, as you can see, and when you finish go back to the first point, and now you have the polygon. Okay, I will choose move so I can move anything as I want. Okay, now how to do the translation. To do a translation, from here you will have reflection about line, reflection about point, reflection about circle, rotation around point, translation or translate by vector, and dilate from point. Now we are reflecting, we are translating by vector. Let's do this. To translate an object, remember I choose from here translate by vector, and now choose the polygon and after that the vector. For example, if I want to move 2 units to the right and 1 unit up, how to do this? Start from any place as you want. You can start from 0. I will start from here so I can show you. This is the starting point of my vector. I said 2 units to the right and 1 unit up, and place the point. Now I have the image. I'll choose move again. This is the image. Okay, if you want to change the color or want to change anything in the image, you can choose settings and you will find color. You can change anything you want. Okay, so guys, that's how to do translation using GeoGebra. Okay, let's go back to the presentation. Okay, now you can see the presentation, right? And of course now you can see how I can do the translation any way I want in GeoGebra. Okay guys, I want you to try this by yourself, and this is an easy way for you to check your answer anytime if you want to solve something by yourself. Okay guys, let's move to the next slide, the next question. And this one, of course I'm not going to graph, this is points, and I want the coordinates of the image. The first one, who can help me?
Can answer, Mr.
Who's this?
Abdullah Dahran.
Abdullah, you did before. I want someone who didn't answer before.
Okay.
Thank you. Ibrahim
Mustafa
Anwar,
Nafar.
can you answer? Ibrahim
Yes,
Anwar.
what is the question?
Okay, question number 7. You have the point G, 2 and 5. I want the image of the point after reflection over x-axis. Yes?
Negative 2 and 5.
When you reflect a point over x-axis, you opposite the y-coordinate, right? Not the x-coordinate. So it will be
And 2 and negative 5.
great. Thank you, Ibrahim.
Okay.
Muhammad Ramadan.
It will be 4 and 3.
Great. And who else? Mujtaba.
Okay. This will be 0 and negative 7.
Great. Again. 0.
0 and 7.
Yes, because we are going to opposite the y coordinate. Thank you. Okay. Now in this question, we need to draw the triangle ABC and find its image after reflection. And the first one, number 10, across x-axis. I want in question number 10, I want someone to help me to give me the coordinates of the image of the triangle ABC. I mean A prime, B prime, C prime. In the first one, when you reflect it across x-axis. Okay, I want someone who didn't answer before. Anyone? Ali Yusuf, can you use your mic? No? Ali? Okay, Abdul Majid, can you use your mic? Okay guys, anyone ready to help me in this question? Anyone who didn't
Me,
participate?
mister.
What's this?
Mujtaba.
Mujtaba, you did before. You did share
Thank you.
before. You're welcome. I want someone who didn't answer before. Bandar? Muad, can you use your mic?
Yes, I can.
Okay, the first one, number 10. Ibrahim
Yes.
will be.
It will be 1 and negative 2
Great.
and,
And
2
B
and
prime.
negative
Great.
B prime will be 2 and negative 7,
Excellent. C. C prime.
5 and negative 1.
Great. Thank you, Maz. So that was easy. I want someone to give me the coordinates of the image after a reflection across y-axis. Okay, Muhammad Ramadan.
Negative 1 and 2, negative 2 and 7, and negative 5 and 1.
Excellent. You're great, Muhammad. Thank you. Okay. Okay, the last one here, I have a line. So I can't do the same. I should draw. Okay, when you graph, you will find this is the original one and this is the image. And here I have the line through negative 1, 5 and negative 1, negative 2. Okay, negative 1, negative 2 here and negative 1, 5 is here. And this is the image of this triangle after reflection across this line. And the coordinates of the image, A prime is here, that's negative 3 and 2. B prime will be here, negative 4 and 7, and C prime will be negative 7 and 1. Okay guys, back to GeoGebra, so I can tell you how to do the same as I did here. Okay. Okay. At first, before I move to reflection, if I want to do another translation to the same object, now you can see GeoGebra, of course, right? Guys, can you see GeoGebra?
Yep.
Good. So
Yes,
if you want to change the translation, if I want to translate this brown one to the left 1 unit and down 2 units. Okay, let's see how to do this. I will just, this is the starting point of the vector. I will change the end point of the vector. Okay. The vector is something like array, but have a starting unit, a starting point, and has end point also. Okay, so it has length and has direction. So I will change this. I said I want 1 left. I will move this point. As you can see, the image is moving with me. 1 point to the left and 2.2 units down. So this is the image. You can do this and move to any place. Okay, you can do this anyway. So that's how to do reflection. Okay, let's remove this. I will delete this. Okay, now I want to do, as we said, that was the translation. Now for reflection, how to do reflection? We have reflection about line. To do reflection about line, you should have a line. So now I can't do reflection unless I have a line. So I will draw a line. For example, if I have this line and I want to reflect this object across this line, just choose from here reflection about line, choose the object, and after that choose the line. This is the image. Now you can change the settings and do as you want. I'll change the color. Okay. Now if I change the line, the image will change also. Okay. So if I want to change the line to any place else, any other place, so I will have the image. Okay. Okay. What if I want the reflection? I will remove this. What if I want the reflection across a point that is on the figure? So I can choose it, reflect about line. This is the figure, and I will reflect it across BC, or for example CD. I will reflect it across CD. So I will choose CD, and as you can see, we have the image here. Okay, so this is how to do reflection. Okay guys, so it's reflection about line. Okay, back to the, let's go back to the slide. I give you this way to make sure that you can check your answer even if you don't have anyone to tell you if your answer is correct or not. Okay? Okay guys, let's move to the next slide. And this one, it's rotation. Can anyone tell me in this question number 13, this figure has a rotational symmetry or not? If it does, find the angle of rotation. The first one, 13. If I rotate this figure, if I rotate this figure, so no one. So of course guys, for number 13, if I rotate this figure, it will come back to the same place, it will cover itself. Okay, it has rotational symmetry. This side I want to move it to be here. So if I draw a line vertical and a line horizontal, I can move the point from here to here. So this is 90 degrees. So the first one, yes, it has rotational symmetry, and the angle of rotation is 90 degrees in the positive direction, of course, as well in the negative direction. But in the general form, we use the positive direction. Okay. Number 14. Anyone?
Can I answer?
Yes. Number 14.
It don't has this. It doesn't
Excellent.
has rotational.
Great. This one, no rotational symmetry. Great, Ahmed. Thank you. Ahmed Gannas, are you here? No.
Yes.
Okay, Ahmed. In this one, what do you think? If I rotate this face, it will cover itself again?
How is it like?
Do you think if you rotate this, it will come to the same shape again? And what's the angle, if you can? Okay, guys. Ahmed, I think you didn't know the answer. Anyone know the answer? Anyone knows the answer? Anyone else?
No rotation.
No rotational symmetry? Okay, guys, that's correct. There is no rotational symmetry here. Guys, here I can find axis of symmetry. And if you think that I can rotate 180, for example, to get the same figure again, if you rotate this 180, the eyes will be down and the mouth will be up, right? So to come back to the same place, you should do 360. And in this case, this is not rotational symmetry. Okay, guys. Now in question 16, 17, and 18, we need to graph the image after rotation 90, 180, and 270 about the origin, of course. Okay, let's do this. Use GeoGebra again. I can do this. This is for number 16, 90 degrees. And this is the original one, of course. The brown is the original one, and this red is number 16. This green is 17, and 18 is this one, this black one, or gray one. Okay, now I'll tell you, this is the last thing I will do today. I will tell you how to do this using GeoGebra. Guys, you know, we can do rotation 90 degrees, change places, and opposite the first in the image. 180, don't change places, just opposite the two coordinates. In 270 degrees, change places first, and after that opposite the second in the image. Okay, let's go to GeoGebra, and I'll stop sharing the slide and go to GeoGebra. Now you can see GeoGebra, right? Okay, guys, I don't want this, so I will erase all of this. And now I don't want this also, I will remove it. I need to do rotation. To do rotation, I should have a center of rotation, a point. So I will get a point and place a point in the center of rotation, which is the origin. Okay, I can rename this point as I want. You can rename it. Of course, this is the origin. I will rename it O capital. So this is the origin. And now, from here, the geometry tools, choose rotation around point. After that, choose the figure, the polygon, and after that choose the point. As you can see, there's a question about the rotation angle of rotation, and the direction counterclockwise or clockwise. So I need this one to be 90 degrees, so I will write here 90 and okay. This is the image, guys. So in this case I have this image. I can change, of course, the settings and change the color as I want, and I can do rotation again for the original one around the origin with any other angle, for example 180 degrees. So this is the new one. You can change, of course, the settings. Okay, guys, now you know how to do rotation. This one, the first one, is 90 degrees and this one is 180 degrees. Okay, I think you can now do the same. You can change anything and you can try this by yourself to check your answer. Okay guys, tomorrow inshallah we will continue the same revision. Thank you guys, that's all for today. Goodbye.
Thank you, teacher.
Thank you, teacher.
Thank you, teacher.
You're welcome. Goodbye. Thank you too.
Thank you, teacher.
Thank you too.